Hi, everybody. Welcome back. Today, we're going to start taking a look at unfactoring the polynomial to get back where we started. Instead of thinking it as unfactoring, I want you guys to think of it instead as undistributing. So undistributing. So all that multiplication stuff that we did last week, we're going to go through and undo it this week. So the first thing that you always want to look for when you're trying to factor by grouping or factor in general is you want to look for a GCF like we did yesterday. You want to make sure you have 4 terms when we factor by grouping. So you have to have 4 terms. This method is only possible if you have 4 terms. If you have any more or less than that, you cannot do factoring by grouping. The next thing that we do is we divide the problem in half. And then we're going to factor each half of the problem like we did in yesterday's notes. Your final step is to write your parentheses. So when we go through this, we are going to kind of break it down. The first step of all this is to look for a GCF. So if I look at letter A, I have 9, 12, 18, and 24. Right away, that comes to my mind, I see that all these numbers are divisible by 3. So the first thing I'm going to do is I'm going to divide every single individual piece by 3, and I'm going to rewrite it. The 3 comes out front, and then I'm going to write everything that's left inside. So 9 divided by 3 is 3x to the third. Negative 12 divided by 3 is negative 4x squared. Negative 18 divided by 3 is negative 6, and then my x. And then finally, 24 divided by 3 is a positive 8. Now that I factored out my GCF, the rest of this seems a little bit easier. So like the step said earlier, we want to divide our problem in half. So I'm going to divide it right here. And when I go through and do this, I kind of think of it as the underline squiggle method. So in the first part, I'm going to underline it. I am looking for a number or variable or variables that I can divide both of them by. So like yesterday, we learned that the first thing we do is look at the numbers. So 3 and 4, the only number we can divide both those numbers by is 1. So it doesn't really matter, but I'll write it down. And now I'm going to look at my variables, x to the third and x squared. Well, what's the one that they both have in common? That's my x with the lowest exponent, so x squared. That's what I can take out of the first half of the problem. So I'm going to go through and rewrite that. So I have 1x squared times, and now I divide. 3 divided by 1 is 3. x3 over x2, well, I had 3 x's. I took 2 away. I'm left with just 1. And I'm going to do the same thing on the second part. Negative 4 divided by 1 is negative 4. I had an x squared, but now it's written out front. So that is the end of my first parenthesis. Now, the deal here is your parentheses must match. So let's see what happens here when I go to the swiggled part. When I look at negative 6 and 8, what number can I divide them both by? Good, I can divide them both by 2. However, this minus sign must accompany this GCF, so I'm also going to put a negative sign with it. So when I write down this number, it goes right here, minus 2. And then I'm going to divide everything out, watching my signs very carefully. Negative 6 divided by negative 2 is a positive 3, and I still have my x. 8 divided by negative 2 is a negative 4, and close my parenthesis. Do you all see that neat thing that happened here? Both of my parentheses match. If you factor by grouping correctly, you will have both of your parentheses match. And that means you're on the right track. So that parenthesis that matches, that will be my first part of my answer. All of that outside junk, I like to call it, that all goes into my second parenthesis. 1x squared minus 2. Oh, wait a second. Do you remember that 3 that we divided by in the beginning? That goes in my front. So when we do this, if we were to go back and box it out and expand this fully, we should get back to our answer where we began with. Let's go ahead and look at another one that doesn't have a GCF. So looking at letter B, 3, 2, and 3, 2, there's nothing I can divide all of them by, so I can jump straight to dividing my problem in half and doing the underline squiggle method. So looking at the first half, dividing by 3 and 2, is there any number I can divide by besides 1? Nope. So I'm going to go to my variables. So if I look here, okay, I have an x squared and an x. Well, which one has the lowest exponent? You guessed it, the x. So that's what I'm going to divide out and write in front of my parenthesis. So 3x squared divided by x is just 3x. Negative 2x divided by x is just negative 2. That x is written out front. Now I'm going to go to the second half of my equation, the part that I squiggle. If I look at that 3x minus 2, the only number I can divide by is a 1. And the sign in the middle tells me it's a positive 1. And then I write my parenthesis. Well, 3x divided by 1, it's still just 3x. Negative 2 divided by 1 is still negative 2. So to double check I did this correctly, I'm going to look at my parentheses. Yes, they do match. So that is my first parenthesis of my answer that I write down. Now, all of that outside junk, that comes together, my x, and then plus 1 to form my second parenthesis. All right, let's go ahead and look at another one. Looking at letter C, I have 2, 2, 3, 3. Again, the only number I can divide all those by is 1, so there is no overall GCF. I can go straight to dividing my problem in half and figuring out the GCF of each half for grouping. So if I look at 2x squared and 2x, what can I divide them both by? Well, they both have a 2 in common, and they also both have an x in common. So that 2x gets written out front, and now I divide. 2 divided by 2 was 1. X squared over x is just x. Now I go to the second part. 2 divided by 2 is a positive 1. Well, I had an x, but I wrote it out front, so that's it. Now I'm going to look at the second half of my equation. Right away, I see that I have a negative sign in the middle, so I'm going to write a negative. And then I have 3x and 3. What can I divide them both by? You guessed it, a 3. So minus 3 is what gets written down. And now I divide. Negative 3 divided by negative 3 is, good, 1. And don't forget your x. And then again, negative 3 divided by negative 3 is still 1. Remember, it's positive. And close my parenthesis. Do my parentheses match? Yep, they sure do. That means I did something right. And so now I can just write my parentheses. 1x plus 1 is the one that duplicates. All that outside junk goes together to form my second parenthesis. I have a 2x in green, and I have a minus 3 in blue, and that's all my second parenthesis. Okay, let's go ahead and look at one additional problem. This one looks crazy. As soon as you see that you have a lot of variables in all your terms, and as soon as you see that the numbers get rather large, that should be your clue that you're going to have a GCF. So the first thing I see when I look at this is every single term has a P. So that means that they all have a GCF of a P. Now I'm going to look at my numbers. Okay, I have a 12, a 10, a 36, and a 30. What is the smallest number written up there? Right, a 10. So if I think about my factors of 10, 1 times 10, 2 times 5. I'm going to start with my highest number, 10. Can I divide 30 by 10? Yep, okay. Can I divide 36 by 10? Oh, no, I can't. So 10 is not my GCF. Now I'm going to go to the 5. Can I divide 30 by 5? Yeah. Can I divide 36 by 5? Nope, can't do it. So 5 is not my GCF. Now I'm going to look at the 2. Can I divide 30 by 2? Yes. 36 by 2? Yep. 10 by 2? Yeah, still going. 12 divided by 2? Yes. I can divide every single term by 2. And they also have that P in common. So when I do this, I'm going to take that 2P, just like I did in example A, and write it out front, and then I'm going to divide everything out. 12 divided by 2 is 6. P4 over P is now P to the third power, because I took one away. 10 divided by 2 is a positive 5. P3 over P is now P squared. Negative 36 divided by 2 is, great, negative 18. P squared, but now I took a P away. I'm left with just P. And finally, negative 30 divided by 2, great, is negative 15. I had a p, but now I divided it out. So I have no more p's. So now that I went ahead and looked for my GCF, I'm working with a lot smaller numbers, and it makes it a heck of a lot easier. So I can go through and divide my problem in half. So looking at the green portion, 6 and 5, what's the biggest number I can divide them both by? A 1, so it doesn't really matter. So looking at the p's, what's the smallest exponent I have? P squared, right. So p squared is what goes out front. So that's the only thing I can divide them both by. So p squared is staying out front. So I had 6p to the third. My 6 is still there. So p to the third divided by p squared leaves you with just p. Now I go to the second number in the front half. Well, the number 5 didn't change, so plus 5. I had p squared, but now I divided it out, so it's all gone. Now I can look at the second half of my equation. Oh no, bells and whistles going off. I have a negative sign in front of my middle term, so I'm going to write my negative and ask myself, what can I divide both 18 and 15 by? Right, they're both divisible by 3. So minus 3 is what goes in the middle. And now I divide. Negative 18 divided by negative 3 is a positive 6. I still have my p. And then negative 15 divided by negative 3 is a good positive 5. Oh, check it out. My parentheses match. Yes. So now which one duplicates? You got it. 6p plus 5. And who are all my outsiders? Well, that p squared and that minus 3. Uh-oh, what am I forgetting? You guessed it, that GCF I divided in the beginning. So don't forget that 2p. Because again, in order to factor this correctly, I should be able to expand this all out and multiply to get back to where I started. Great job today. If you have any questions at all, feel free to rewatch the video or bring those questions to your math teacher. Thanks. I think you guys have the skills necessary to go ahead and get a start on your classwork. Have a great day. Bye.